All right, so good morning, everyone. Um,
Hello,
Good
doctor.
morning.
Good morning.
hello. We're gonna to have presentation. As I said, as I uploaded the information, it's gonna be next week, but I'll change this one to the last week. So which is gonna be no, basically we have one more week left, actually. We need to do presentation next week, right? And I still don't have the presentation titles, just only two. And I do not have like groups and presentation titles. I don't know what are you waiting for. So please make a group and send me the presentation title. This is
So,
about
doctor,
the, yeah.
sorry, do we have any specific topics for presentation?
There is a general topic, chemistry in medicine. This is a field from which you
Uh-huh.
can choose the topic. So whichever topic
Uh-huh.
you want, if it fits this general area, that's okay.
Uh-huh. It could be related to our field. I mean, related to the industry field. Yeah.
Yeah, just the field of chemistry in medicine. Whatever there is relationship between chemistry and medicine, everything is okay.
Okay. And as you said, we have to make four membrane group. Yeah.
Say it again, please.
Four member.
Yes, there must be four members in the group because
Okay.
we cannot do like individual one because there are 35 people. So we need to make a group.
Okay. We will send you. Doctor. Thank you.
Yeah, one more thing is that I want you to do the quiz next week because we also need to do the quiz. If you know, we have one more option to do the quiz.
Okay.
So I'll set the time, maybe we'll do like that way. So 9 a.m. will be the quiz, or any other day which we agree on. We can make a quiz, um, but and then we'll do presentations.
That's
I'll
great, doctor.
I'll I'll send I'll send out the email. So it's gonna be 10-point quiz. So presentation is 10-point, quiz is also 10-point.
Oh, 10 point. That's great, doctor. It's completely helpful for us.
Okay, any specific questions?
Doctor, the quiz gonna be after midterm topics.
Yes, the quiz will be only about after midterm topics. Actually, it will be only about organic chemistry.
Okay, okay, thank you.
I'll send out the email about the topics, yeah?
Doctor, when you give us the marks of the second lab,
What about second lab?
when you give us the marks,
I already uploaded marks about the second lab.
okay, doctor.
Mhm. Anything else?
Let me check, doctor.
All right, so let's just continue. I just want to finish something from the last quiz, last lecture. It's about, yeah, so there was, yeah, something we didn't discuss. I really want to quickly finish it. So I want to talk about reactions of alkanes because last time we discussed about alkanes. This is hydrocarbons, saturated, so-called saturated hydrocarbons with the general formula CnH2n plus 2, right? We talked about like nomenclature of these hydrocarbons, but we didn't finish about reactions. So one reaction is combustion reaction. So what is combustion reaction? This is basically a reaction with oxygen. So basically the burning of hydrocarbons. For example, when you are cooking something, you are burning the methane, and that process is combustion. Okay, so during this combustion, usually there is a heat evolves because it's exothermic reaction, and you have carbon dioxide and water. So this is like complete reaction of combustion. So you have hydrocarbon, you have oxygen, and what is the product? It's carbon dioxide and water. Okay, usually this is what is happening during burning and combustion of hydrocarbons. Okay, one more reaction, that's a halogenation reaction, and it goes under the light or under the heat. And what is happening is that, so you have, for example, methane, and if we react with chlorine is a halogen. So chlorine, bromine, fluorine, these are halogens. And during reaction, we have complete substitution. If it goes to completion, there is complete substitution of hydrogens by chlorine. And we have tetrachloromethane and HCl. So it can go step by step. For example, you have first substitution of hydrogen, right? And one molecule of HCl, then the second substitution, again, one molecule, and so on until it goes to completion, like CCl4 plus 4 HCl. Okay, it says over here what are names for that: chloromethane, dichloromethane, chloroform. Maybe you have heard about chloroform, right? So this is carbon tetrachloride. One more thing is about cycloalkanes. So the naming is really simple. A little bit what is different is that the formula is changed for cycloalkanes. So again, there is only single bonds. There is nothing else, only single bonds. And we need to remember that alkanes have only single bonds. And once they make a cycle, the naming is really simple. So you just add cyclo in front of the name. So if it is propane as a chain, if it is cycled, then it's going to be cyclopropane. Okay. For example, this is cyclobutane, right? So if there is a substitution, say we have a cycle, but on top of that, there is a substitution of methyl group, right? So the parent compound is going to be cyclohexane, because we have 1, 2, 3, 4, 5, 6. It's a cyclohexane, but since we have a substitution, then simply it's going to be methyl cyclohexane. Okay, that's it. But if we have two substitutions, so we have one and the other one, right? So what we're going to do is that, again, it's alphabetic naming. We will find the one which has priority in terms of alphabetics. So it's going to be ethyl, right? So this is this one. And we start numbering from there. So if the substitution at this point, it's going to be 1. Then we have two ways to go, right? Either this way to number the carbons. But what we need to look at to see where is the second substitution, okay? And find the shortest way to that substitution. In this particular case, we go this way. So we will not go that way. So it's going to be 1, 2, 3, 4, 5, 6. And then name is going to be 1-ethyl, 3-methyl, cyclohexane. Okay. Yeah, so this is basically it about reactions of alkanes. There is not much to remember. This is reaction of combustion, which is reaction with oxygen, and the other reaction is reaction with halogens, say bromine, chlorine, fluorine. Okay, so these are halogens. So and this is what is going to happen during this reaction. Okay, this is it about alkanes. Do you guys have questions? Okay, so I'll go to the next topic, which is going to be alkenes. Here. So we'll go to alkenes. So we studied alkanes, but now let's just talk about alkenes and alkynes. So what is difference between these all hydrocarbons? All of them are hydrocarbons, right? Only there is only carbon and hydrogen in the formula. But now we have different equation. For alkenes, it's CnH2n versus CnH2n plus 2. And for alkynes, it's CnH2n minus 2n minus 2. Okay. So what is main characteristic of alkenes and alkynes versus alkanes? So alkenes and alkynes are unsaturated hydrocarbons. Unsaturated. Why it's unsaturated? Because they have double bonds in there. Okay. So for example, alkenes have carbon. Okay, let me change this color. So alkenes have carbon-carbon double bonds. And alkynes, they have carbon-carbon triple bonds. So that's the difference between alkanes, alkenes, and alkynes. So for example, this beautiful flamingo's color is because of diet which contains alkenes. So as I said, we have carbon-carbon double bonds. And that's gonna be make hydrocarbons as alkene, okay? And we change the naming from alkane to alkene. So A and E is changed to E and E, all right? For example, if we have butene, so it's gonna be butene because we have one double bond, all right? And the position of double bond is very important in order to make like numbering of the alkene. Okay, in this particular case it's one butene, and if it is two butene, it's going to be in the middle like this way, so it's going to be two butene. Okay. Yes, so now let's just see how to name alkenes. It's very much similar to alkanes, but again, we need to consider, first of all, we need to consider where is the double bonds. Where is the double bonds in the molecule, all right? The first of all, we need to name the parent compound. So how to do it? So we need to count how many carbons are in there. So we see here that there are 5 carbons, and since we have double bond in there, so we know that this is alkene, and in this particular case it's going to be pentene because it has 5 carbons, right? And the other case is when the hydrocarbon has triple bonds, so we have 1 2 3 4 5 6 carbons, so the name is going to be hexyne. Why it's Y-N-E? Because we change ending A and E to Y-N-E because we have triple bonds. So for triple bonds, it's Y-N-E, and for double bonds, the ending is E-N-E. Okay, so in this particular case, since we have 6 carbons, it's going to be hexa, right? Hexa. But since we have additionally triple bonds in there, it's going to be hexyne, as it's written over here. Now let's see if we have a substitution, what we have to do. Say we have a straight chain. Okay, that's fine. We just count carbons, 1 2 3 4 5 6. So it's going to be hexyne. But if we have substitution in there, as it is in this case, right? So what we should do, first of all, we need to find where is the double bond. In this particular case, the double bond is in the middle. So either you start from here or you start from here, it's in the middle. So now we need, if it is in the middle and there is no point of starting whichever side we start numbering, then we need to look at substitution. The second priority is substitution. So the substitution here is from this side. So because of that, we start numbering from this side. So it's going to be 1 2 3 4 5 6. Okay. But if you look this case, you see here that the triple bond, which is priority, is from this side. So we don't care where is the substitution after that. So since it is closer to the one side, we start numbering from here. So 1, 2, 3, 4, 5, 6, 7, right? Now let's see how to proceed with substitution. For example, as I said, like if we want to write the full name, so this is pentene because we have just straight chain of 5 carbons and 1 double bond in there. So it's going to be pentene. Now let's just look at a little bit more complicated case. So we have 1, 2, 3, 4 carbons in the chain, but we have substitution. On top of that, we have 2 double bonds. Now let's look which one has priority. So since we have substitution closer to this part, closer to this double bond side, right? So we start numbering from here. Otherwise, if we didn't have this one, we could start either from here, because these double bonds, both of them are close to each end. So it doesn't matter, right? But because we have substitution there, then we will start from the side where we have substitution. So then we have 1, 2, 3, 4. That's a butane, but because we have 2 double bonds, it's going to be butadiene. So di means 2. Okay. So because of that, we have ene at the end, but we are adding this di because to indicate we have 2 double bonds. So let's just write the name. So we have 2-methyl, which is indication of substitution. Then we have the first double bond at first carbon over here, right? So 1, this is what we are writing here, 1. Then we have the second double bond at 3. So we are writing 3, and then butadiene. Okay, do you guys have questions about this? Or is it clear? All right, so the next question here. So what we see is that we have triple bonds in the structure, right? So we have triple bonds, and we see that these triple bonds are close to this side. So we start numbering from this side. So 1, 2, 3, 4, 5, 6, 7, 8, and we have 1 substitution. Okay, so it comes to the carbon, which is 7. So it means that we have 7-methyl, 2, because we have on the second one triple bonds over here, 2-octane. All right. Now, and the cycle, if we have cycled alkene, so we'll talk about this one a little bit more. Just some aspects of these alkenes. There is in naming, there are some of names are like historical names. For example, for this guy, this is going to be official name ethene, but usually people call it ethylene. Maybe you have heard about ethylene, right? Also, for this one, the official name is going to be propene, but people call it propylene. All right. Also, this is going to be ethyne, because we have triple bonds, right? And only 2 carbons. So it's going to be ethyne, but people call it acetylene. Maybe you have heard about acetylene. Okay, so these are 3 cases mostly, which because of historical some kind of things are mostly called like this way. But you can call also different ways, say ethene or propene or ethyne. So it's also okay. About cycloalkenes. So you can see that we have double bonds here, right? What we need to do is that, and if we have double bonds and also we have substitution, so we somehow need to find out how to do the numbering. So again, the double bonds is a priority. So we need to look where is the double bond. And in this case, and then since we have substitution, once we start numbering of double bonds, we need to find the way where we cover up the double bonds first. So it means that if we start numbering here, we need to go this way because we need to cover up the double bonds, okay? And then go to the shortest way to the substitution. So you can see here the second case over here, it says do not begin here. Why? Because if we start numbering here, it means that we need to go this way, right? Because we need to cover up double bonds, and then we need to go this way towards the substitution, and then it comes 1, 2, 3, 4, 5. So it's a longer way. So instead of that, we can go shorter way, like as I showed in the previous, like first case. All right, so now let's just look at, do you guys have about naming any questions here? Is it everything clear? Stop me if something is
Doctor, in the
not.
last one, in the
Yeah.
last one.
Okay, so to number the cycloalkenes, see what I'm saying, that first of all, we need to find double bonds, okay? And then we need to, if we start numbering, we need to cover up double bonds. You know what does it mean is that, again, first of all numbers need to be assigned to the double bonds first. Okay, so if we start here, and also we have substitution, right? So we have substitution. So we need to cover up double bonds and then find the shortest way to the substitution. This is why we start here. Is it clear or not?
Yes, doctor, it's clear.
Okay, so what about the student who asked me about the question?
Clear, Doctor, clear.
So the opposite way cannot happen, because if we start here, we need to go this way, then we come to the substitution, which is now 5. So 5 is long way, so we need to go this way, okay? Right, about structures. These are very important concept about cis and trans isomers. Very important concept, because it changes many things in alkanes. All right, so the structure is different for all these 3 types of hydrocarbons. So this is alkane, this is alkene, this is alkyne. And you can see that alkyne is a straight one, alkene is a flat one, and alkane is like 3D tetrahedral. Okay, so it's very important, all these structures for hydrocarbons. Again, since we have double bonds, many things are changed for alkenes and about the structures of that. So we can distinguish sides of the shape and ends of the shape. You can see we have double bonds here, right? So when we have structure like this, so this is going to be side and this is going to be end. Okay, so I'll just show why we need this one. So I mentioned about cis and trans isomers and cis and trans positions of the functional groups. So I'll just explain simply what does it mean. So if you look at this picture over here, I'll just make this kind of axis, which goes through the double bond, right? So, and you can clearly see that hydrogens are from one side and methyl groups are from the other side, right? Now, and this is called cis, when 2 identical functional groups are at the same side from the double bond axis. Now I'll make axis here on the second one. Okay, so what do we see? Now we see that hydrogen is from one side, the other one is from the other side. Methyl is from one side, the other methyl is from the other side, right? So now we have trans configuration. This is called trans. Okay, so these are like kind of 3D pictures. So this is just chain straight butane. So here I don't think that you can make any trans or cis configuration, because it's impossible to have like from the other sides like functional groups. But here you can do it. And again, so if you have at the same side these methyl groups, this is cis, different side, that's trans. The same about hydrogen, okay? For example, be careful about to understand what is cis and trans isomers, because, for example, if you look here, so this is one butene. Even though I can draw it like this way, right? These are not isomers. This is the same thing. If you rotate this guy, you will make this. So no problem here. Okay, so you will make the same thing. So this is not isomers. This is just the same molecule. Okay, but if you look here on the second case, look at this one. So let's just try to rotate actually one of these molecules. Say we rotate this one this way. So this will go up, this will go down, right? This will go down, this will go up. And we will never make this one. Okay, so I can draw it quickly. So if you rotate the one which I mentioned, it's going to be like this. Now compare this one to this case. It's not the same, right? These are different. So because we have on different sides. So because of this, these are isomers. Okay, so you see, if I make this one through the carbon double bonds, carbon-carbon double bonds, you can see that hydrogens are at the same side. I'll continue this make to this axis through the carbon-carbon double bonds. You can see hydrogens are on different sides. So these are trans, the other one is cis. Is that clear here how we assign cis and trans?
Yes,
Yeah,
Doctor.
doctor, it's clear.
Okay.
But
Yeah.
for exam, you want to naming this structure or in reverse?
Okay, so you might have a question, say identify if there is a trans or cis isomer. Okay, you need to identify this kind of thing. And about naming, you will have naming of the compound. Yes, what we discussed, you will need to name the compound as we discussed in the previous slides, like 2-methyl, 1-methyl, diene, or whatever it is. And on the quiz, you will have something like that to do. But as about in the quiz, it will be like that. Also on exam, you will have something like that. By the way, exam is offline. Do you guys know that?
Yes, Doctor. Yes.
Yes, doctor.
Yeah,
Yes.
so I want you to be prepared. I mean, I'll give you topics, but you will need to prepare it very well. So it's on offline. So on a quiz, yes, you will need to identify whether it's cis isomer or trans isomer. Okay, if it can have a cis configuration or trans configuration, I'll give you the molecule, and you will need to tell me on a quiz, but that is it cis or trans? Okay.
Okay, doctor.
So this is just to show how important is that cis and trans isomerization. So you can read it by yourself. By the way, how we see the light and how we see the dim, like dark light, it depends on the change of isomerization of the carotene. You know carotene, right? So this is actually the name of the chemical, which is also found in carrot. And this is why it's called carrot, or opposite carotene. So very often people say you need to eat carrot in order to have good vision. So this is the change of a cis, and see here, look at here at this point. So you can see that both hydrogens are from the same side. So now you strike the light, and then hydrogens are on different side. Okay, so this is how you see it. Of course, the process is complicated. This is what is shown here, but we will not go in details. I'm not going to ask to write like the the reaction like this one. Okay, so the beta carotene goes to vitamin A, then it's transformed to cis retinol, 11 cis retinol. You see here, these are cis structure, and then so this is cis, right? So cis rhodopsin, and then from cis rhodopsin, once the light strikes, this is light, it goes to trans rhodopsin. So this is going to be like like this way. Okay, so this is quite important. This is why I'm saying that cis and trans isomerization, we need to know that, because it really affects on some kind of processes in the organism. So now let's just talk about reactions of alkenes and alkynes. This is a little more than for alkanes because we have double bonds. For example, we need to, so the mechanism is because of breaking of these double bonds in order to make single bonds. So we can do hydrogenation to add hydrogen to alkenes to make alkane. So if we add hydrogen to alkene, we will make alkane. Okay, and the same thing, we add hydrogen to alkyne, we'll make alkane. All right. Okay, so what are reactions? One reaction is halogenation. Halogenation reaction. You remember we discussed about halogenation of alkanes, and we found that, say, if we have CH4 plus chloride, it's going to be CCl4 plus 4HCl. Right? So what is difference here between alkenes and alkanes? That alkenes can take all these chloride and there will be no HCl generated, okay? Because it has a lack of hydrogens, right? It can break these double bonds and add this chlorine in that double bond. See here? So this is how it goes with chlorine and alkene. What about hydrogenation, adding hydrogen to alkene? I'm sorry, hydrohalogenation. So hydrogenation is the same. You just add hydrogen and you make alkene, okay? But hydrohalogenation is HCl. For example, it's hydrohalogen, okay? HCl, right? Or HBr, or HF. So what is happening here? I want you to pay attention to this Markovnikov's rule. It's not difficult at all. It's a simple rule. So now let's just look at alkene. This is alkene over here. And we add HBr, hydrohalogen. Look at the colors. So H is in green, Br is red. And now look at colors of the arrow. So H goes to the carbon. So we have two carbons over here, right, around double bonds. So we need to target double bonds and those carbons which are around double bonds. So we have two carbons over here. So H will go to the carbon which has more hydrogens with it. So this particular one has two hydrogens. So H will join this carbon and Br will join this carbon. Okay, because it has less hydrogen. Then we'll make something like this. Okay. Is it clear, this one, this Markovnikov's rule?
Yes, doctor.
Okay. One more thing is hydration. So this is what you guys need to go through and study. So we have hydration, halogenation, hydrohalogenation, and hydration. I know you might be like, these words are mixing, but if you study what is behind, say hydrogenation is adding hydrogen. Halogenation is adding chlorine, bromine, fluorine. Hydrohalogenation is adding HCl, HBr, HF. And hydration, because it's hydration, it's just adding water. Okay, H2O, which is water, right? So if we do so, we will make an alcohol. For example, if we add water to ethylene, we will make ethyl alcohol. Okay, that's the ethyl alcohol. Simply, so water is split like this way, right? So this is water, the same thing, right? So one of the hydrogens will join one carbon and OH will join another carbon. And this is what is gonna show, what is shown here, okay? You just split the water in two parts, hydrogen and OH, and just connect it with carbon. Now, how many connections we have with carbon? 1, 2, 3, 4. Okay, 1, 2, 3, 4. All the times we need to have 4 bonds with carbon. We should remember that. One more important thing with alkenes is polymerization. You guys know, right, that we have polymers, a lot of polymers around, and polymerization is a very important part of production, also some medical purposes. For example, a lot of dental implants are made of polymers, right? It's more complicated than this one over here, but they are made of polymers, and they are made from starting from some monomers, which contains double bonds. This one, so what is the mechanism behind? So I'll rewrite this molecule, which is ethylene, like this way. So C, H, and now we have one more double bond, right, to deal with. So every bond, like stick, is like a pair of electrons, okay? So this is the same thing as pair electrons and the stick, right? So I can write pair of electrons this way and pair one electron this way and the other one here, okay? Now I can write another molecule, the same type of molecule, C, H, and one electron here, instead of double bonds. So then what is happening that this is paired up, okay? And now we have another molecule made this, okay? Here they were paired up, this one, C, hydrogen, 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 and hydrogen. And then one more electrons here at the very end and very top. Then we can add another molecule and so on. We can make some like row like this way. So very long polymer, okay? We can indicate the polymer like this way. So we have a monomer. So this, we can rewrite this one also this way. Okay, so